Hello everybody, welcome to Mastering Solutions. Let's make a list of all the given values for this question. We're given the lambda, or the wavelength. In this case, they have a 633 nanometer laser, 10 to the negative 9. Sorry, that's a weird one. Okay, so 10 to the negative 9. They also give us the L in this case, which is the diffraction pattern, 50 centimeters. So L is going to be equal to 50 times 10 to the negative 2 meters, which is also 0.5 meters. I like to do this one. I think it's safer. W, or the width of the central maximum, is given, and that is 3.77 millimeters, so times 10 to the negative 3. And what are we trying to solve for? We're trying to solve for the A, which is the width of the opening, or in this case, the width of the wire, because the book talks about how if you have a object like a wire or a hair or a fiber, one of the other questions did a fiber, it acts just like a slit would and will also give us a diffraction pattern with a light. So kind of interesting. So what we need to do is we need to figure out what is the actual width of the wire, and then if it matches up with what it says, basically. The equation that we'll be using for this is W, or the width of the central maximum, is equal to 2 times lambda times L, all divided by A. We're trying to solve it for A, so let's multiply A over and divide W over, so they just swap places. So A is equal to 2 lambda L over W. Now we have all the values here, so let's plug that in and see what our answer is for how wide the actual width is. So A is equal to 2 times lambda 633 times 10 to the negative 9 meters, times by L, which we said was 50 times 10 to the negative 2 meters. All that gets divided by W, or the width of the central maximum, and that is 3.77 times 10 to the negative 3 meters for millimeters. Let's put that in our calculator. So we have 2 times 633 times 10 to the negative 9 times 50 centimeters, 10 to the negative 2. All that's divided by the W, which is 3.77 times 10 to the negative 3. So the width is 1, 2, 3, 4, 5, 6. So we have 167.9 microns. And then they tell us that the actual width is 170 microns. 170 microns. And we need to figure out what is the actual width. Did it fall within this tolerance of 1%? So to do that, we will take the actual width, the 167.9 microns, minus what it should be, so the difference between those two, and we divide it by what it should be, 170 microns. So the difference divided by the actual give us a percentage of what the difference is. So we have 167.9, minus 170. So we have a difference of 2.1. Oops, I did that backwards. So we take the actual minus, or excuse me, what it should be divided by, there we go. So, all right, so we get a difference of 2.1 microns, and we divide that by what it should be. So we have a difference of 1.2%. So it is outside of the tolerance of what it should be, so it does not pass.